Hello students, today we are going to discuss the ordinal utility analysis. So far we discussed the cardinal utility analysis and some of its limitations. The grave limitations of cardinal utility analysis led economists like Higgs and Allen to think of alternatives of measuring consumer satisfaction. So they came up with a solution which was called the ordinal utility analysis. In the ordinal utility analysis, it is believed that the consumers can only rank their preferences of commodities. That is, consumer can rank commodities XYZ according to first rank, second rank or third rank in terms of their order of preference. So unlike the cardinal utility analysis, the ordinal utility analysis dismisses the quantitative measurement of utility or satisfaction that consumers derive from consuming different commodities. The ordinal utility analysis makes use of a tool called indifference curve. The indifference curve represents different combinations of two commodities which gives the consumer equal satisfaction. The word indifference means that the consumer has no clear choice among different combinations. The objective of the consumer is to maximize his satisfaction. So it does not matter to him whether he gets satisfaction from consuming commodity X or consuming commodity Y. It suffices him to say that he derives a certain level of satisfaction whether he is consuming single commodity only or both commodities. So this is how the name indifference curve came. And the indifference curve is based on certain assumptions. The first assumption is the ordinality of utility. Utility is ordinal in nature. That is, in the cardinal utility analysis, we said that consumer can express the exact number of utils that he derived from consuming a certain commodity. But the ordinal utility analysis believes that consumers can only rank the commodities in terms of his order of preference. So this is the first assumption. Second one, it assumes rationality from the part of the consumer. The concept of rationality in economics is different from other branches of knowledge. In economics, the rationality implies that the consumer always tries to maximize his welfare, and he always prefers more welfare to less welfare, more satisfaction to less satisfaction, more revenue to less revenue, less cost to more cost, greater cost. So this is the implication of rationality, and here also it is assumed that the consumer is rational and therefore he is trying to achieve the maximum satisfaction out of his given outlay. And the third assumption of indifference curve is transitivity. The assumption of transitivity says that the consumer, if the consumer prefers commodity or combination A to B and combination B to C, then the consumer will always prefer combination A to C. That is, if A is greater than B or A is preferred to B and B is preferred to C, then it is clear that the consumer will prefer A to C. This is the assumption of transitivity. And the fourth assumption is consistency in choice. Consistency says that if he prefers a certain combination at one particular period of time, that is, if he prefers combination A to B, if he prefers combination A to B, then he cannot prefer combination B to A in another period of time. This is the meaning of assumption of consistency. And fifthly, the theory also assumes that diminishing marginal rate of substitution. Marginal rate of substitution is the rate at which one commodity can be substituted at the margin without affecting the total satisfaction. And according to the ordinal utility hypothesis, this marginal rate of substitution goes on diminishing as the consumer substitutes more and more use of one commodity for another commodity. And these are the important assumptions of, and there is one more assumption also, which is called non-satiety. The assumption of non-satiety implies that consumers' needs are unsatiable, non-satiable. That is, he can buy innumerable number of commodities. So that is the sixth assumption. So these are the six important assumptions of ordinal utility analysis. Utility can be measured ordinally. Consumer is rational. Consumer's choice are transitive. They are consistent. And the marginal rate of substitution is diminishing. And consumer is not satiable. So these are the important assumptions. And now we will deal with the two that we use in indifference ordinal utility analysis, which is called the indifference curve. The indifference curve can be represented in a table as well as in a graph. First, we are measuring indifference curve in a table. So first we have different combinations, then commodity X and commodity Y. There can be combination A, B, C, D, E and F. In combination A, he consumes 1 unit of X and 12 units of Y. The combination 2, he consumes 2 units of X and 8 units of Y. 3 and 5. 4 and 3. 5 and 2. 6 and 1. Okay, so these are the combinations that the consumer is consuming. In the first case, he is consuming 1 unit of X and 12 units of Y. In the second combination, he is consuming 2 units of X and 8 units of Y. In combination C, 3X and 5Y. Combination D, 4X and 3Y. Combination E, 5X and 2Y. Okay, let's for the time being, let's just assume that the consumer has only got 5 combinations. Consumer has only got 5 combinations A, B, C, D and E. And here it is assumed that the consumer is indifferent between any of these combinations. That is, if he is offered combination A, B, C, D and E, he will not have a clear choice. That is, he gets equal amount of satisfaction from all these combinations. So it is practically unimportant whether he chooses A, B, C, D or E, and therefore consumer does not have a strong preference to any particular combination. He will like A because he has a certain level of satisfaction from it. He will like B equally because though the number of Y falls from 12 to 8, the number of X increases from 1 to 2. So the loss in satisfaction that is happening due to the reduction in the number of Y consumed is compensated by the increase in the number of X consumed. Similarly, when he moves on to combination C, the number of Y falls to 5, but number of X rises to 3. So the loss in satisfaction that results due to fall in the number of Y consumed is compensated by an increase in the number of X consumed. As we go to combination D, number of Y consumed falls to 3, number of X consumed increases to 4. Here, the loss in satisfaction due to fall in the number of Y's to 3, that is minus 2Y, is compensated by 1 unit increase in the consumption of X, and the same thing happens in the case of combination E also. So, for every fall in Y, the consumer is being compensated by an increase in X, so that he is neither worse off nor better off. That is, he is indifferent between these combinations. So he is indifferent between A, B, C, D and E because all these combinations gives him equal level of satisfaction. The same thing can be graphically expressed. We have two axes, X and Y. On the X axis we measure commodity Y. On the Y axis we measure commodity X. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, and 12. So the first combination was 1x with 12y. Second combination was 2x with 8y. Third combination was 3x with 5y. Fourth combination was 4x with 3y. And the fifth combination was 5x with 2y. So this is combination A. This is combination A. This is combination B. This is combination C, D, and E. So all those 5 combinations that we saw in the schedule have been plotted on the graph. Now we are joining these points together and we get the indifference curve. So the consumer is indifferent between A, B, C, D, and E. Similarly, here we will be indifferent along any point on this indifference curve, because every fall in y is compensated by an increase in x, or every fall in x is compensated by an increase in number of y that is consumed. So the consumer is ultimately indifferent between any of these combinations, and therefore it is called an indifference curve. So an indifference curve is locus of points of different combinations of two commodities that gives the consumer equal level of satisfaction. Here the locus of points are A, B, C, D, E, and there are an infinite number of points along this indifference curve on which the consumer is indifferent. So this is the indifference curve. And now we are going to analyze the situation of marginal rate of substitution. In the earlier part of the class, we explained diminishing marginal rate of substitution as an assumption of ordinal utility analysis. Now we are going to explain the marginal rate of substitution and the diminishing marginal rate of substitution, and how the diminishing marginal rate of substitution gives the indifference curve the shape that it has. The marginal rate of substitution, as already remarked, is the rate at which one commodity can be substituted for another without there being any change in the level of satisfaction. For example, here the consumer is substituting x for y. Consumer is substituting x for y. He is increasing the consumption of x and reducing the consumption of y. So he is substituting x for y. So it is called MRS XY. MRS XY, marginal rate of substitution of x for y. Okay, so what is the MRS here? He is sacrificing, or he is giving up 4 units of y. He is giving up 4 units of y and is getting 1 unit of x. 1x. He is giving up 4 units of y and getting 1 additional unit of x at point A. At point B. As he moves from point A to B, he gives up 4 units of y and adds 1 unit of x to his dt. But he is at the same level of satisfaction. Now, when he moves from B to C, he is giving up 3 units of y. When he moves from B to C, he gives up 3 units of y. 8 minus 5 is 3. And what is his gain? He is gaining 1x. Okay, is gaining 1x. So this is the marginal rate of substitution of x for y at point C. At B, he is giving up 2 units of y. From 5 to 3, he is giving up 2 units of y, but he is adding 1 unit of x. Here the marginal rate of substitution is 2. Okay, absolute value of marginal rate of substitution is 2, because he is substituting 1x in the place of 2 y's. And when he moves from D to E, he is sacrificing 1 y and he is getting 1x in return. So MRS xy is, absolute value of MRS xy is 1 here. So that is the marginal rate of substitution, the rate at which one commodity is substituted for another. Here the rate at which x is substituted for y. Initially 4y's had to be given up in order to add 1x, then 3y, 2y, and finally 1y, single y. So why does this marginal rate of substitution diminishes? So we have seen that marginal rate of substitution is diminishing. This is called the diminishing marginal rate of substitution. Okay, why does it fall? There are two reasons why marginal rate of substitution fall. The first reason is that the commodities are not perfect substitutes. Okay, x and y are not perfect substitutes. If they were perfect substitutes, in order to add 1x, he would have to reduce only 1y. He or she would have only to reduce 1y. So by reducing 1y, the consumer could add 1x and be on the same level of satisfaction. If he reduce 4y, then he would have to add 4x to remain at the same level of satisfaction if the commodities were perfect substitutes. That is, the loss in satisfaction from a certain number of reduction in the units of y consumed would have to be matched by equivalent number of increase in x, so as for the consumer to remain on the same level of satisfaction. And the second reason why this marginal rate of substitution is falling is that as the consumer has less and less stock of a commodity, the utility from that commodity increases. That is, when he is giving up y, his stock of y is falling. His stock of y is falling. That is, initially he had 12 y's and the marginal utility of y, the utility of y was quite low. But as the number of y's diminished, his desire or intensity of desire for that commodity is higher, and therefore he is willing to sacrifice less and less units of y in order to have more units of x. At one point of time, he is equally preferring the two commodities, each unit of the commodity. He is willing to sacrifice only 1y for 1x. Okay, this is the diminishing marginal rate of substitution. So in this class, we discussed what is ordinal utility analysis, the assumptions of ordinal utility analysis. Then we discussed in detail how the ordinal utility analysis, the tool of ordinal utility analysis, that is indifference curve, can be shown in a tabular form as well as in a graph. And finally, we discussed in detail the marginal rate of substitution, diminishing marginal rate of substitution, and how marginal rate of substitution is falling. And one additional point, that final point I want to mention, is that it is because of this diminishing marginal rate of substitution that the indifference curve gets its convexity. You can see that the indifference curve is convex to the origin. Convex to the origin. So it is convex to the origin because of diminishing marginal rate of substitution. If marginal rate of substitution were constant, then you would get a straight line. There is a straight line as indifference curve, and if marginal rate of substitution were increasing, you will be getting a concave curve, just like our production possibility curve. But here, because marginal rate of substitution is falling, and we have diminishing marginal rate of substitution, the indifference curve are concave to the origin. Thank you.